This demo covers problem 2 from chapter 14. In that problem, you were given some information about what's known as an inflation indexed bond. Um, Technically, they're called Treasury Inflation Protected Bonds, or TIPS. And if you buy a bond of that type, you're given a beginning par value, but then periodically that par value rises if we have inflation. The bonds also have coupon payments. In our example, the annual coupon payment is, our rate is 6%, but it's paid semi-annually. And then the current price is $890. Again, these numbers don't agree with what you have in your problem. I'm just setting these numbers up for demonstration. The problem has 4 parts. The first question we're asked to answer is, what is the dollar amount of the first interest payment? And even though I have this set up in Excel, you can do this on a calculator. Our interest payment is determined by the coupon rate and the par value. The coupon rate is 6% a year, but you want to divide that by 2 because they're made semi-annually. So we're receiving 3% every 6 months. And then you just take that 3% and multiply by the par value of 1,000. So we'll receive $30 in interest for the first coupon payment. Now, if there's inflation, which there conveniently is in the problem, the par value will rise the next time period, and you'll receive the same coupon rate, but it'll be on a higher par value. So the dollar interest you'll get the next time period will be higher. They want us to calculate the par value in a year. Well, the starting par value is 1,000, and it will increase by the inflation rate. Well, the inflation rate is 1.03%. To calculate the new par value, multiply the inflation rate by 1 plus that 1.03%. So 1.03% converted to a decimal is 0.0103. And I need to add that to 1 to figure out the ending par value. Another way I could do this is calculate the increase in the par value, and the increase would be the 0.0103 times the par of 1,000, and then just add the initial starting par of 1,000 to that, and I'll get the same ending value. One way might make more sense to you than another, which is why I'm showing you both ways. Our new semi-annual interest payment will be that 3%, or the 6% annual divided by 2, times this new par value. So our new semi-annual interest payment will be 3% times 1,010.30. So instead of getting $30 in interest, we'll get $30.31. The fourth question asks us to calculate the par value at maturity if inflation is 3.5% a year and the bond has a 10-year maturity period. To solve for this one, there's a few different ways I could do it. I could go, the starting par was 1,000, and I want to multiply it by 1 plus this rate of 0.035. So 1.035, but for a period of 10 years. So that little caret symbol is raising this to the exponent of 10. So the ending par value would be $1,410.60. Another way I could do that is to use the time value of money calculator and solve for the future value. Our rate would be the rate of inflation, which I've already forgotten, so I have to go look. 3.5%. So I would enter this 3.5 as my rate. There are 10 periods. My starting par value or present value is 1,000. There's no payment, and I want to solve for the future value. So I'm just going to compute future value. and it'll return a negative future value, but it should be the same answer of 1410 or $1,410.60 that I calculated in Excel.